Howdy, howdy, this is Mr. Potter. In today's episode, we're going to be talking about how to do a binary tree. We're still doing our turtle programming. We're still using the recursion that we talked about last time. But what we're going to do is we're going to talk about a tree. So the question is, what makes a tree? So I know that if I were to go outside and look at a tree, I would see some type of trunk, probably with a nice little knot hole in it. And then this trunk is going to split off into a couple of branches. And then each of these branches will split off into a couple of other branches. Here's a branch here, here's a branch here. And then each of these are going to split off into a couple of branches, and each of these are going to split off into a couple of branches. But each of these branches should be smaller than the level that they were before. My trunk here really should be my biggest branch. It should have the longest length. And so the idea is that these lengths that we're talking about should be smaller. Maybe this is length minus 10 or something like that. And this would be another length minus 10. Till eventually I get to the point where all I have are these little twigs up here. This would kind of get closer and closer to what we talked about last time, our base case. So our iteration, the idea that we're getting closer and closer to a base case. We start off with our full length, then took 10 away, then took 10 away, and eventually we get to our base case. So in our program, what we're going to be doing is we're going to be drawing a line segment. And then at that point, we're going to branch off. We're going to make a line segment this way, we're going to make a line segment this way, and then each of these are going to make line segments this way and this way. But again, with that same caveat that these branches are going to be a little bit shorter than the ones that came before. That way we're getting closer and closer to that base case. So I have my base case out here, really these tips up here, which have length of 0. But my iteration comes from the idea that here's my length minus 10, and here's my length minus another 10, my length minus another 10. Each of these are getting smaller each time I go. And what's also important is that I'm going to make a path, do a split, and then come back. Because the idea is that once I go forward, make a split, and then come back, the idea is that once I come back, I can then make the next split if necessary. So we're going to talk about how to implement that in our code. So we're going to jump to sculpt.org, our usual suspect when it comes to writing a Python program. We're going to scroll down a bit here, get rid of this code, and substitute our own. So mistapotta, and we're going to import turtle library, and we're going to instantiate a turtle. So T gets turtle library, turtle constructor. And then I want to define a tree. So remember that we use def tree, and inside here I'm going to have branch length. And of course the idea is that I put this colon over here and everything's scoped. Everything that's indented 4 units is going to be part of this. But again, I need to establish the base case. So I'm going to establish a base case. So if the branch length is greater than 5, then we want to do the following code. So now we're ready to talk about what we're doing. We're going to go forward a bit. We're going to go ahead and go forward whatever our branch length is. And then we're going to turn right. Let's go ahead and turn right 20 degrees. And then we're going to call on our tree with a new branch length. Let's say branch length minus 10. And by the way, this is our iteration. The idea is that our iteration is where we're cutting the length by 10. We're getting closer and closer to a situation where our branch may not be bigger than 5 pixels. But keep in mind, this is only going to give me the right branch. Now what I need to do is I need to go to the left, not just 20 degrees, but I also need to make the other branch will be 20 degree offset. So we're going to say t.left 40 degrees. So the idea is that I'm going to have a branch that goes straight up. Let's talk about what this would look like. I'm going to have a branch that goes straight up, and then I'm going to go to the right 20 degrees, draw a branch, and then go to the left 40 degrees to draw my other branch, and then come back down. That's how I'm going to do this. So I've got this. So here's our t.left 40. And then we're going to do call on tree again with a branch length minus 10. And we're going to call that our other iteration. We have two iterations in this loop. Both of these are splitting off. So my one tree starts off with one trunk, and then that trunk has two branches. Each of those branches will have two branches on them. So each of these branches here will have two branches that sprout off on them. And then each of those will have two branches that sprout off, and until the length is triggered by this this branch length is greater than 5. As soon as I hit that, then I'm going to run into a problem. So I've created the right branch, then I create the left branch. Now I want to get back to my starting point. So I need to go to the right 20 degrees. That means I'm now centered between the branches. So now my mouse, my little turtle pointer is pointing straight up. And now I can go backwards. And so what I'm going to do is tell my turtle to go backwards, whatever my original branch length was. Keep in mind, this is the original branch length that I went forward, the original branch length that they gave me. So this is my code. Notice that I have my base case, but I also have two situations of iteration because I'm calling upon tree twice, once for the right branch and once for the left branch. So what I'm going to do now is I'm going to jump back down to the base level here. And I want to set it up so, of course, it'll look like a tree. I want this thing to be facing up. So I'm going to say t.left 90 degrees. That's going to make my turtle face straight up. And then I want to tree, and we'll go ahead and do a tree with, I don't know, how about 40? And see what that looks like. So let's try this, see what this looks. Hopefully I haven't made a bad error. So there's my tree going up. And something's wrong with the way it doesn't seem to want to go back down. It made this branch, there's my 40, then the 30, then the 20, then the 10, and it tried to go back down and didn't quite do it. Let's take a look at that again. 40, 30, 20, 10. It kind of tried to do branches, but they ran out of situations here. So if the branch length was greater than 5, then we did forward, right 20, tree branch, t dot left, and then t dot backward, I think, maybe? Yeah, backward. That's what it is. So notice what's happening is that it's drawing out these branches. And it drew out, this branch had 40, 10 less than that makes 30. So each of these branches are 30 pixels long. Each of these branches are 20 pixels long. And each of these leaf tips are 10 pixels long. If I were to change these to say 8 and 8, then I'm going to have more branches because it goes from 40 to 32 to 24 to 16 to 8. And so I can get something that looks a little bit more branchy. I can get a lot more branches out here because each of my branches, including my stump, started off shorter. The other thing that I can do is I could take each of these angles and kind of make them a little bit quirkier. Let's say I wanted to make that 17 degrees. And we'll make this right 43 degrees. And then in order to get back, 43 minus 17 is 26 degrees. So now if I do this, then what will happen is I'll end up with something that looks a lot more natural, a lot less computer generated, where these angles kind of don't exactly match. So notice that because I introduce these numbers and because the right is smaller than the left, it kind of looks like my tree is blowing a little bit to the left. The other thing that I can do is I can actually make these iterations a little bit different. If I was to make this 11, and if I was to make this, let's say 9, then I could actually go down here. Let's make my tree start off at 50. And you'll see that with the branches being a little bit different lengths, it'll look a lot more like a tree. And so this is something that you'll see a lot in movies. They'll introduce these quirkier numbers, these numbers that don't quite make the same value. Now again, I do still have a little bit of predictability. These leaf tips, it always looks like the left branch is longer than the right branch, or excuse me, the right branch is longer than the left branch. No, I was right the first time. The left branch is longer because I'm taking more away from the right branch. But it is possible to kind of introduce random numbers to make these a little bit more random, and that's what happens if you look at the movies that Pixar or DreamWorks make, those computer rendered drawings, they're doing this idea. This actually gets us to the idea of a fractal. We'll talk a little bit more about fractals later on in this unit, but this gets us into that idea. So what we've done today is we've used the idea of using recursion twice within a function. So a function calls upon itself more than once, and that allows us to get this branching situation like we have in this tree. I still have symmetry. Notice I still have the same number of branches on the right as I do on the left. That's something we'll deal with next time. So once again, this is Mr. Potter. Thank you for watching. Have a great day.